Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When people think about keeping applications online, they often imagine servers, networks, and databases. Yet, one of the most critical services behind the scenes is the Domain Name System, or DNS. DNS translates human-friendly names like www.example.com into the IP addresses computers actually use. Amazon Route 53 is AWS's managed DNS service, providing not only the basics of name resolution, but also global routing controls, failover capabilities, and integration with AWS services. For learners, think of Route 53 as the phone book of the Internet combined with a smart traffic controller. It ensures users can find your application reliably, and that traffic is routed according to rules you define. Hosted zones in Route 53 come in two types, public and private. Public hosted zones are used for domains that must be reachable from the Internet, like a company website. Private hosted zones, by contrast, exist within an Amazon VPC, meaning the names are only resolvable from inside your cloud networks. Beginners should picture public zones as billboards visible to the world, while private zones are like internal office directories that only employees see. Choosing the correct zone type ensures DNS entries reach the right audience without exposing internal resources unnecessarily. DNS records are the building blocks of hosted zones. Common types include A and quadruple A records, which map names to IPv4 and IPv6 addresses respectively. CNAME records map one name to another, often used for subdomains. Route 53 also supports alias records, a powerful extension that allows domain names to point directly to AWS resources such as Elastic Load Balancers, S3 buckets configured for static websites, or CloudFront distributions. Beginners should see alias records as shortcuts that connect friendly names to dynamic AWS infrastructure seamlessly, eliminating the need to hardcode IPs. Routing policies in Route 53 define how traffic is distributed. The simplest option is the simple routing policy, which directs queries to a single resource without complexity. Weighted routing introduces percentages, allowing you to split traffic among resources, such as sending 80% of traffic to one server and 20% to another. This is often used for gradual deployments. For learners, this is like having two cash registers in a store and directing a certain share of customers to each, balancing traffic intentionally. Latency-based routing allows Route 53 to direct users to the AWS region with the lowest latency based on measurements of network performance. This ensures that a user in Europe connects to an EU region rather than one in the United States, reducing delay. Beginners should think of this as a GPS navigation system automatically choosing the fastest road rather than the closest one geographically. Latency routing prioritizes performance, enhancing user experience without requiring manual intervention. Failover routing is one of the most powerful Route 53 features. With this policy, Route 53 monitors the health of endpoints using health checks, automatically failing over to a backup when the primary becomes unavailable. For example, if your main website goes down, traffic can be redirected to a disaster recovery site. Beginners should imagine a backup generator kicking in automatically when power fails. Failover routing ensures availability by detecting failures and rerouting users instantly. Geolocation and geoproximity routing add geographical intelligence to DNS. Geolocation routes queries based on the user's location, for instance, directing all North American users to one endpoint and European users to another. Geoproximity is more advanced, allowing biasing of traffic towards certain regions, even overriding strict geography. Beginners should see geolocation as sorting mail strictly by country, while geoproximity allows rerouting some traffic from nearby borders for load balancing or compliance needs. These policies give fine-grained control over where users land. Multi-value answer routing provides another layer of resilience by returning multiple IP addresses for a single query. Clients can then choose among the provided endpoints, often using health checks to avoid unhealthy ones. This is not true load balancing in the ELB sense, but provides redundancy at the DNS level. Beginners should view this as providing several phone numbers for a contact. If one doesn't answer, try the next. Multi-value answers provide DNS-level resilience in a simple, effective way. Health checks in Route 53 monitor endpoints by sending periodic requests, confirming that services remain online. These can be integrated with CloudWatch alarms for deeper monitoring and automation. When a health check fails, routing policies like failover or multi-value can shift traffic to healthier endpoints. Beginners should imagine a doctor performing regular checkups on servers. Only those passing the test continue to receive users. This keeps DNS smart and responsive, not static. DNSSEC, or DNS Security Extensions, provides integrity for DNS responses by digitally signing records. This helps prevent attacks like DNS spoofing, where malicious actors try to redirect users to fake destinations. While advanced, learners should at least know that Route 53 supports DNSSEC signing for added trust. Beginners can think of this as stamping official seals on envelopes so recipients know the message wasn't altered in transit. Security at the DNS layer complements encryption at the application layer. Time to live, or TTL, values define how long DNS records are cached by resolvers. A short TTL allows rapid changes but increases query volume and cost. A long TTL reduces overhead but delays propagation of updates. Beginners should picture this as expiration dates on tickets. Shorter ones mean more frequent renewals, while longer ones reduce effort but risk holding outdated tickets. TTL strategy is about balancing agility with stability, and Route 53 gives control over that balance. From an exam perspective, learners must know which routing policy or feature applies to which scenario. Simple routing for single endpoints, weighted for gradual rollouts, latency-based for performance, failover for resilience, and geolocation for compliance. Multi-value answers provide redundancy, alias records link to AWS resources, and health checks enable automation. Beginners should expect exam questions that present a user or business requirement and ask which Route 53 feature meets it. Matching requirement to feature is the skill being tested. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Route 53 integrates seamlessly with other AWS services like application load balancers, network load balancers, and CloudFront. By pointing alias records directly at these services, DNS names remain stable even as underlying resources scale or change. This means users always reach the right endpoint without manual updates. Beginners should think of it as having a permanent street address that always points to your house, even if the house is renovated or expanded. Integration with ELB and CloudFront makes Route 53 the natural glue between DNS and AWS's scalable infrastructure. Private hosted zones extend Route 53 into your VPC, creating internal DNS names only resolvable from within your cloud networks. This allows organizations to maintain friendly names for internal services, like db.internal.local, without exposing them publicly. Beginners can think of this as a company's internal phone directory, useful to employees but invisible to outsiders. Private hosted zones provide convenience, security, and consistency for internal workloads, while keeping the external DNS clean and limited to public-facing endpoints. Split Horizon DNS, sometimes called Split View DNS, combines public and private zones for the same domain name. For example, app.example.com might resolve to a public IP when queried from the Internet, but to a private IP when queried inside the VPC. This allows different audiences to see different answers depending on their location. Beginners should view this as showing different maps to visitors and employees. Outsiders see the public entrance, while insiders see the back entrance for staff. Split horizon designs simplify access without creating multiple confusing domains. A common use case is multi-region failover. Route 53 health checks and failover policies can route users to a primary region under normal conditions and automatically shift to a secondary region if the primary fails. For learners, this is like having a backup office. When the main office closes unexpectedly, employees are redirected to the alternate site automatically. On the exam, any scenario describing disaster recovery or continuity planning often maps to Route 53 failover records. Hybrid naming is another capability, particularly important for organizations with on-premises infrastructure. Route 53 resolver endpoints and rules allow on-premises DNS queries to resolve AWS private zones and vice versa. This ensures that applications spanning both environments can consistently use the same names. Beginners should think of this as linking two phone directories so calls can be made across both companies seamlessly. Hybrid naming reduces friction and supports smooth migrations between on-premises and AWS. Resolver endpoints are the technical building blocks for this hybrid DNS. Inbound endpoints allow on-premises systems to query Route 53 private zones, while outbound endpoints let AWS resources resolve on-premises names. Routing rules determine how queries are directed. For learners, this is like setting up operators who know when to consult the internal directory and when to forward the call externally. These controls keep hybrid environments consistent, with DNS bridging both sides. Traffic steering for deployment strategies like blue/green or canary releases is another Route 53 advantage. Weighted routing policies let you send a small percentage of users to a new version while the majority remain on the stable one. If the new version performs well, traffic can gradually increase. Beginners should picture this as opening a new checkout counter and initially sending only a few customers there. If it works smoothly, more customers are directed to it until it becomes the default. Weighted DNS routing makes safe, incremental deployments possible. Costs in Route 53 are primarily driven by the number of DNS queries and the number of health checks. For high-traffic applications, queries add up, and each health check incurs ongoing charges. Beginners should realize that while DNS itself is inexpensive per request, scale magnifies costs. It's like paying pennies for postage until you're mailing millions of letters. Cost awareness means designing DNS health checks carefully, avoiding unnecessary monitoring while still ensuring resilience. Logging DNS queries helps with troubleshooting and security investigations. Route 53 can log queries to CloudWatch logs or S3, showing what names are being requested and from where. This can reveal misconfigurations, such as clients still pointing to old names, or even malicious activity, such as queries for unauthorized domains. For learners, logging is like keeping a visitor sign-in book. You may not check it daily, but when something suspicious happens, the record is there. Controlling who can change DNS records is critical for security. Route 53 integrates with IAM to restrict changes to specific users, roles, or automated systems. Least privilege should be applied so only trusted administrators can alter records. Beginners should think of this as limiting who holds the keys to road signs in a city. If anyone could swap signs freely, traffic would be chaotic. In DNS, the wrong change can take down an entire application, so tight access is non-negotiable. Naming conventions and governance add order to DNS management. Clear, consistent naming, such as env-app-region.example.com, makes records easier to understand and reduces errors. Without conventions, DNS quickly becomes messy and unmanageable. Beginners should picture a filing system. Without labels, folders are lost in chaos, but with consistent labels, anyone can find what they need. Naming governance ensures DNS supports rather than confuses. Operations at scale. Disaster recovery strategies often rely on Route 53 failover records. When primary endpoints go down, DNS redirects users to secondary or tertiary sites. Combined with health checks, this creates automated continuity. For learners, this is like rerouting traffic to a backup bridge when the main one closes. Route 53 makes these transitions automatic, ensuring resilience without human intervention. On the exam, the key is to quickly match policies to requirements. If the goal is to split traffic percentages, choose weighted. If the goal is best performance, pick latency-based. If it's disaster recovery, choose failover. If it's regional or compliance requirements, geolocation is correct. Learners should train themselves to map question keywords directly to routing policies, as this is a common exam challenge. In conclusion, Route 53 aligns DNS, health checks, and traffic policies into a single service that keeps applications discoverable, resilient, and performant. From simple record resolution to complex multi-region failover, it provides the foundation for global availability. For learners, the key lesson is that DNS is not just about names, it's about intelligent routing, resilience, and governance. With Route 53, AWS elevates DNS into a strategic control point, ensuring that no matter where workloads run, users can always find and reach them securely. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.